Hi, in this video, I'd like to show how to implement basic locomotion in virtual reality, so as to enable us to move around a virtual environment. I'm going to implement both teleportation and continuous motion. Teleportation instantaneously moves the user to a new location, which is a rather comfortable way to cover large distances in virtual reality, while continuous movement is similar to walking in a 3D video game and is more comfortable when the motion is low. This to limit motion sickness. I'll be using the Unity XR Interaction Toolkit, an interaction system that allows developers to use a set of base components to manage interactions as well as locomotion in VR and AR. There are a couple of ways to work with the XR Interaction Toolkit: action-based and device-based. I'll be going for action-based since it offers some interesting advantages by separating physical inputs from behaviors, allowing scenarios like easily switching between customized action maps or assigning multiple controls to trigger the same behavior. Be aware that the XR Interaction Toolkit is currently in preview. Still, this is a great option if you intend to test an existing Unity project in VR, perhaps for virtual scouting or demonstration purposes. So let's start by creating a new project. And for that, I'm going to use Unity 2021.2. And since I want to aim for high-end visuals, I'm going to select the HDRP sample scene. If you're not familiar with the high-definition render pipeline sample scene, this environment does a great job at demonstrating the capabilities of the HD render pipeline, and is divided into three different areas. So you have this outdoor space, then you have an indoor space with light coming through a large window, and finally we have a completely indoor space lit by artificial light. And I would say that this is a relatively large space to navigate in virtual reality. So I would like to implement a teleportation system, but in places like in front of this nice little garden, I would like to be able to walk slowly around it. So for that, I'm going to implement a continuous move system as well. So let's start by adding a couple of packages. So Window, Package Manager, Unity Registry, and scroll down to the bottom to find the XR Plugin Management package and install it. So what this package does will provide a simple way to manage different plugins for XR devices. Then I will also need the XR Interaction Toolkit package. And since this package is still in preview, I will have to add it by name. So click on the plus icon at the top left corner and add package by name, and just enter com.unity.xr.interaction.toolkit. Wait a few seconds. If this is the first time installing the XR Interaction Toolkit on your project, you can just skip this alert by clicking No Thanks. Then you'll also want to install some starter assets. This will add some very useful presets to your project. So we can check them in the project window. Click on the new starter assets folder. And here we have a list of presets for different XR Interaction Toolkit components. To use them as default properties, we need to click on each of them and then click on the Add button at the very top of the inspector window. So let's do that for each of them. And now in the project settings, under Preset Manager, you will find each preset assigned to a XR Interaction Toolkit component. So whenever we add one of these components to to our scene, it will be pre-populated using our presets from the starter assets folder. You will notice that the action-based controller has two presets assigned to it, one for each controller. So in order for it to know which one to assign, we can use this filter field. So for the right controller, I'm just going to write right, and for the left one, left. Now, still in the project settings window, you can select the XR plugin management tab, and here you can install the plugin that you need based on the device, the XR device that you're going to use. I will install the Oculus plugin under the desktop tab. Now an additional subsection will appear, and in my case is called Oculus. And here I will change the stereo rendering mode from multipass to single pass instanced. And what this does is save some calculations by sorting out things like culling or shadows in a single pass instead of two. Because in VR, everything needs to be rendered twice. And finally, we have to ensure that the same setting is set in the HDRP assets. This is found inside the sample scene assets folder and settings. And by default, I think we're using medium quality, but I'm going to check that this is set for all of them. So now we can start working on our scene. And the first thing I'm going to do is to remove any existing cameras. And in the sample scene, we just have one. So I'm going to untag it. And actually, I'm going to disable the parent object because it contains some components to move around the scene, but these are meant for a desktop setup using mouse and keyboard. So let's completely disable this. So now let's click Game Objects, XR, and add a XR Origin action-based game object. This will also add an interaction manager component to the scene, which is required to manage the interactions between interactors and interactables. While if you expand the XR Origin game object, you will see that there is a camera offset game object as a parent to the main camera, a new one, a left-hand controller, and a right-hand controller. Let's select the main camera and set a anti-aliasing technique. I'm going to use the fast approximate anti-aliasing because it's the faster one, but you could also try other techniques. Next, I want to reset the transform settings of the XR Origin game object. I'm going to change the orientation so it faces the sphere at the center of the platform. And I'm going to move it a little bit so we are right in front of the sphere. You will notice that inside this game object there is an XR Origin component, and with a tracking origin mode setting, which I'm going to set to floor. This is going to let the VR device itself tell the system how far is the headset from the floor. Since I'm using action-based components for Locomotion, I have to explicitly activate the actions so they listen to device input. And for that, I just need to add a input action manager component to the scene. So at the root of my scene, I'm just going to create an empty object, give it a name, and assign the relevant component to it. So input action manager. And expand the action assets dropdown. Click on the plus button and select our default input actions from the starter assets folder. Now we can start implementing the Locomotion system. So let's select the XR origin game object and add the Locomotion system component. As I said before, I want to use a combination of teleportation and continuous motion. So I'm going to add the teleportation provider, the continuous move provider action based, and finally also a snap turn provider, also action based. And what this provider does is allow me to turn around by discrete increments. Then I want to uncheck the right hand reference for continuous move and the left hand reference for snap turn. This way I'll be using the left hand controller joystick to walk around the scene and the right hand controller to turn. The way teleportation works is by casting a ray from each controller. And by default, the ray is a straight line that is going to check for collisions with surfaces where to teleport to. Now, in virtual reality, it's common practice to make this line curved, so it's always pointing downwards onto a surface. And for that, we need to modify a setting in each hand controller. So let's go to XR origin, camera offset, left hand controller, and scroll down until we see the XR ray interactor component. And there we want to change line type from straight line to projectile curve. I'm also going to bring down the velocity to something like 8, so the curve will fall closer to me. And then we'll change the default white color to another one. I think I like this. And I will repeat these steps for the right hand controller. So again, change line type from straight line to projectile curve and bring down the velocity to 8. And finally change its default color to this nice light blue. We also need to tell the teleportation system which surfaces to check for collision. So let's start with this platform and add the teleportation area component. As long as there is a collider assigned to the game object or one of the child game objects, the teleportation area component should work as expected. And now let's repeat the same for the other surfaces that we want to step onto. So let's select this one. Let's do the same for stairs. By the way, what I'm doing is not performance friendly. I'm going for simplicity here. Because what you really want to do in a case like this one, where the colliders are more complicated than what we need, you probably want to create new colliders, much simpler ones. And if you want to go even further to improve the performance of your teleportation system, it is advised that you group all the colliders that you use for teleportation using a layer mask and reference it in the teleportation area components. Finally, I want to disable a few settings to make the experience more comfortable in virtual reality. And the first one that I'm going to disable is the lens flare. So I'm now selecting the directional light sun game object and disable the lens flare components in the inspector window. Then I'm going to find the global volume, which in this sample scene is under lighting, volumes, volume global. And I'm going to uncheck things like volumetric clouds, because volumetrics are not recommended for virtual reality. Film grain, motion blur. We should also disable the volumetric fog, but I feel that it takes away a lot from this beautiful second area. So I'm going against the recommendations here, and I will leave volumetric fog on. We should now be ready to connect the VR headset and test the scene. I'm using an Oculus Quest 2 or MetaQuest with a link cable. And for that, I bought a 3 meters long USB 3 cable, and that gives me really good results. So now I'm viewing the sample scene in VR, and I can use the joystick on the left hand controller to slowly walk around, the grip button of either controller to teleport, and the joystick on the right hand controller to turn by discrete amounts. So let's go and see the other areas. So here we have the beautiful garden with the volumetric fog. And at the very end, we have the third and final area with just artificial light. Thank you. I hope you enjoyed the video and see you next time.